Welcome to this session on Mathematics, Chapter 2 Polynomials for Class 10 or Grade 10. We are covering Section 2.1 Introduction. Polynomials in one variable x are the algebraic expressions which consist of terms in the form a multiplied by x raised to power n, where n is a non-negative, that is positive or a zero integer, and a is a real number which is also called as the coefficient of the term. Degree of a polynomial in one variable x is the highest exponent or the biggest power of x in that polynomial. Now let's take some examples. 4x plus 12. This is a polynomial. This is a polynomial with variable x, and this is a polynomial with the degree 1 because highest power of x is 1. Another example, 22y square minus 33y minus 444. This is a polynomial. This is a polynomial with variable y, and this is a polynomial with degree 2 because the highest power or the biggest power of variable y in this whole expression is 2. Another example, 25x cube minus x square plus x minus square root of 12. This is a polynomial. This is a polynomial in variable x, and this is a polynomial with degree 3 because the highest power of x, that is variable x, has got the biggest power or the biggest exponent is 3. There are some other expressions. For example, 8 minus square root of 2x. This is not a polynomial because the power of x is not an integer. Another expression, 1 divided by x minus 8. This is not a polynomial because power of x, that is power of the variable, is negative. Let's take one example of a polynomial. Let it be 3x cube plus 4x square plus 5. In this entire polynomial, items like 3x cube or item, let's say 4x square or 5, each one of them is called as a term of the polynomial. So 3x cube is one term, 4x square is another term, and 5 is another term. Also, we see in this polynomial 3 is the coefficient of x cube because 3 is the number by which x cube gets multiplied. So 3 is the coefficient of x cube. Similarly, 4 is the coefficient of x square, and 5 is the coefficient of x raised to power 0, or 5 is a constant term. Also, a polynomial in one variable could have any number of terms. In the example here, we have shown only 3 terms, 3x cubed, 4x squared, and 5. But in general, there could be any number of terms in a given polynomial. Now let's see what are linear polynomials. Linear polynomials are the polynomials which have degree of 1. Examples are 3x minus 3, square root of 33 multiplied by x, y plus square root of 112. Quadratic polynomials are also called as square polynomials, and they have a degree of 2. Examples are 2x square plus 2x minus 5 divided by 11, square root of 3 multiplied by y square plus 55, or another example is y square plus square root of 2. Cubic polynomials are the polynomials of degree 3. Some examples are 2x cubed plus 2x square minus 5 divided by 11, 3x cubed plus 3x square plus 3, y cubed plus square root of 2. Now let's have a look at the general form of linear polynomials. The general form is ax plus b, or ax raised to power 1 plus b, where a, b are the real numbers and a is not equal to 0. Because if a were to be 0, then this term, that is ax, will become 0 and we shall be left with only b, and hence the polynomial will no longer be a linear polynomial. The quadratic polynomials have a general form of ax squared plus bx plus c, where a, b, and c are the real numbers and a is not equal to 0. And again, a is not equal to 0 because if a were to be equal to 0, then term ax square will become 0 and we shall be left with bx plus c, which is not necessarily, or which is not a form of a quadratic polynomial. Similarly, general form of cubic polynomials is ax cubed plus bx square plus cx plus d, where a, b, c and d are the real numbers and a is not equal to 0. If we extend it, then we can say general form of a polynomial is px is equal to an multiplied by x raised to power n plus an minus 1 multiplied by x raised to power n minus 1 plus an minus 2 multiplied by x raised to power n minus 2 plus so on up to a0, which is only a0 because it is multiplied by x raised to power 0, which is 1. In this expression, all the an's are the real numbers. So an minus 1 and an minus 2, they are all real numbers. And an's are called as the coefficients of the terms. So let's say an minus 1 multiplied by x raised to power n minus 1. In this term, an minus 1 is the coefficient, and the variable in this case, in this term, has x raised to power n minus 1 as its power is n minus 1. And an, which is the coefficient of the highest term, x raised to power n in this polynomial, cannot be equal to 0 because there will be, if this coefficient were to be 0, then there will be no term in x raised to power n. Now let's see what are zeros of a polynomial. Zeros of a polynomial are also called as roots of the polynomial, and these are the values of the variable x which make the polynomial become equal to 0. So if px denotes a polynomial in variable x, then if for a given x, let's say we are given x is equal to k, and if pk becomes 0, then k is called as a 0 of the polynomial. We can put it in more formal manner and say a real number k is called as a 0 of the polynomial px if pk is equal to 0. Let's take an example. Let's say px is equal to 2x square minus 5x plus 2 is the given polynomial. And now let's start placing different values of x in this. Let's start with x is equal to 0. Then the value of px becomes 2 multiplied by 0 raised to power 2 minus 5 multiplied by 0 plus 2, which is equal to 2. And when x is equal to 1, the value of px becomes 2 multiplied by 1 square minus 5 multiplied by 1 plus 2, which is equal to minus 1. And when x is equal to 2, then the value of px becomes 2 multiplied by 2 square minus 5 multiplied by 2 plus 2, which is equal to 0. That is, we can say that when x is equal to 2, the value of polynomial is 0. That is, 2 is a 0 of the polynomial px. Similarly, when the value of x is equal to half, then the p half, that is value of the variable px, becomes 2 multiplied by half square minus 5 multiplied by half plus 2, which is equal to 0. And we can say that half is a 0 of the polynomial px. So in this example, we can say that 2 and 1 by 2 are the zeros of the given polynomial 2x square minus 5x plus 2.